Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life.
Today, we are undertaking a really critical deep dive into the forces driving extreme winter weather across the Northern Hemisphere. We're talking about the big ones, the Arctic Oscillation, the AO, and the one you always hear about when the temperature plummets, the polar vortex, or PV.
And this is a truly real-time analysis for you. Our main source is Dr. Judah Cohen's detailed breakdown from Atmospheric and Environmental Research, posted just this week, December 8th, 2025. So this isn't history. It's a live look at the fight for winter supremacy.
Our mission today is threefold. First, we're going to make sure you fundamentally understand the polar vortex, what it is, and how it gets, knocked around. Then we'll look at the immediate 2-week forecast. And finally, we'll dig into the 3 major competing scenarios that could define the rest of the winter.
Right, because right now the atmosphere is kind of holding its breath, and understanding these 3 scenarios is the key to knowing what kind of winter is actually headed our way.
Okay, let's unpack this, starting with what exactly the polar vortex is. We hear that term, and people either panic or they roll their eyes, but what's the technical definition we're working with here?
It's actually a pretty straightforward concept. The polar vortex is this huge area of low pressure and very cold, swirling air that, it always exists up near the pole.
The poles, right?
Both poles. And that word vortex just refers to the counterclockwise flow of the air. It's a permanent feature that just gets much stronger in the winter and then weakens in the summer.
So it's basically a giant atmospheric fence meant to keep the coldest air locked up north.
That's a perfect analogy.
So if it's always been there, why does it feel like it only became a household name in the last, 10 or 15 years? It's not new, is it?
Not at all. That's probably the biggest misconception. The feature has been around forever. In fact, if you think back to some of the most memorable cold outbreaks in the U.S., like the deep freezes in 77, 85, even 2014, they were all tied to the same thing.
We just have a catchy name for it now.
Exactly. We have a catchy name and much better ways to talk about it.
Okay, so if the fence's job is to keep the cold air locked up, how does it end up causing these extreme cold surges in places like, say, Texas or Florida?
It all comes down to the disruption. When the PV is strong, that fence is solid. It keeps the jet stream, that fast river of air, in a really tight circular path. The cold stays put.
Contained.
Right. But when the PV weakens, that strong circular flow just collapses. The jet stream becomes wavy and rambling. It meanders, and that waviness lets these huge chunks of Arctic air break off and just spill south.
Here's where it gets really interesting, because we have to connect this to the bigger picture. I'm drawing on some context here from the former White House science advisor. If the globe is warming, why are we even talking about extreme cold?
That's the essential paradox, and it's all about the speed of warming. The data shows the Arctic is warming roughly twice as fast as the mid-latitudes.
So the temperature difference between the pole and the equator is shrinking.
Exactly. And that temperature difference, that gradient, is what drives the whole system. A smaller difference means less energy for the PV.
Less energy means the fence gets weaker, wobblier.
Precisely. The PV weakens and becomes much wavier, so instead of universal mildness, which you might expect, you get more variability.
The bigger swings.
Huge swings. You get these massive excursions of cold air breaking south, but at the same time you get plumes of warmer mid-latitude air pushing way north into the Arctic.
Which just accelerates the whole process.
Right. And while the models show it's complex, the evidence strongly suggests we can expect to see more of these extreme temperature swings as that polar temperature difference continues to shrink.
Okay, let's pivot to the here and now. We've got the theory down. What does the real-time AER analysis tell us? For the next 2 weeks, up to December 23rd, is that fence strong or is it shaky?
We are absolutely in a moment of transition. We look at 2 key indices to figure this out. The first is the Arctic Oscillation, the AO.
That's the one that measures pressure over the Arctic.
Right. It's currently negative, which means high pressure is pushing into the Arctic trying to disrupt the PV. But it's predicted to trend back toward neutral, maybe slightly positive.
And what about the North Atlantic Oscillation, the NAO?
That one's crucial for Europe. It's also negative right now, but it's also predicted to trend positive to neutral.
And a negative NAO usually means that blocking high pressure near Greenland, which can spell cold for Europe and the eastern U.S.
It does. So the fact that it's trending away from that suggests a temporary stabilization. The blocking is receding for now.
Okay, so how does this temporary calm down translate into actual weather? Let's start with Europe and the UK.
For Europe, this means the cold is being held back, at least for a bit. The forecast favors a mostly maritime regime air coming off the Atlantic.
So milder and wetter.
Exactly. Normal to above normal temperatures. This is driven by low pressure, or a trough, south of Iceland, and high pressure, or a ridge, across Scandinavia and Eastern Europe. Dr. Cohen basically calls it a slow start to winter.
What about Asia?
Asia's a mixed bag, which really shows you the scale of these patterns. Western and Southern Asia, plus Eastern Siberia, are looking at normal to above normal temps, but there's this persistent cold signal spreading across Western and Central Siberia down into Kazakhstan.
And that Siberian cold is something we need to watch, right?
We absolutely do. It often leads the way for what happens elsewhere later.
Okay, let's bring it to North America. Many of us just went through that big cold snap in early December. What's the outlook now?
That cold snap was a direct result of the PV taking a big hit. Looking ahead, the pattern favors high pressure, that ridging, in the western U.S.
And a ridge in the west usually means a trough in the east.
The atmosphere has to balance itself, so that ridge pushes the jet stream into a deep dip over Canada and the northeastern U.S. This means the west and south get warmer, drier conditions.
While the northeast and Canada stay chilly.
Normal to below normal, yes. But, and this is key, that cold air is predicted to mostly pull back into Canada during the second half of December. It aligns with that stabilizing trend in the indices.
Let's talk about what caused that initial cold snap, though. The PV was called unprecedentedly weak at the end of November. Which brings us to the Rodney Dangerfield of TV disruptions.
I love that nickname from Dr. Cohen, the stretched polar vortex. It just gets no respect compared to the really dramatic, sudden stratospheric warmings, the SSWs.
And SSW is when the vortex actually splits apart.
Right. It's a huge dramatic event. A stretched PC is, well, it's just elongated into an oval. It reaches further south, but it doesn't split.
But why is this stretched state so important for us down here in the mid-latitudes?
Because the research shows it is the most reliable cold bringer. A study highlighted in the sources found that extreme cold and heavy snow, the big events, overwhelmingly happen when the PV is in this stretched state.
More so than with the big SSW splits.
Far more frequently, especially for the central and eastern U.S.
But the stretch doesn't last as long. And that must create a huge forecasting headache.
A massive one. These stretched events are short and sharp. You get an intense burst of cold, and then the atmosphere immediately tries to reorganize. So the key question for the holiday period is, how long is this intermission before the next disruption kicks in?
And that leads us straight to the long-term outlook. We know December can be a rogue winter month, not always a great indicator for what's to come. So beyond this current uncertainty, what are the three competing scenarios for January and February?
Dr. Cohen lays out 3 doors for the rest of the winter. And even though models are currently leaning toward a short-term strengthening of the PV, the bigger picture suggests 3 very different paths.
Okay, let's walk through them. Scenario 1, the runaway train.
This is the mildest path. In this scenario, the PV successfully fights off the disruption, strengthens into a beast of a PV, and becomes almost immune to what's happening below.
It likes the cold air up tight.
Super tight. And that results in mild, maybe very mild, conditions across much of the northern hemisphere for the rest of the winter. The historical analog is the winter of 2019-20, which did exactly that.
Scenario 2, the knockout punch.
This is the one winter weather fans are hoping for, especially in Europe. High latitude blocking comes roaring back, you get more stretched PVs, until boom, a true sudden stratospheric warming happens in January or February.
And a full SSW can really change the game for weeks, right?
Weeks, maybe even a month or more of intense, variable cold deep into the mid-latitudes. Think back to winters like 2005-06 or 2017-18.
And the final one, scenario 3, rinse, lather, repeat.
This is the chaotic winter. It's not one big event, but a constant tug of war. You get these repeated, disruptive, stretched PVs, followed by brief periods where the PV tries to get strong again.
So just back and forth between mild and severely cold.
Constantly. It's a real roller coaster. The most famous analog for this is that wild winter of 2013-14, or even just last winter.
So we've got these 3 very different possibilities on the table.
We do. And what's really crucial here is that while the runaway train, scenario 1, is seen as the least likely right now, the atmospheric pattern setting up for late December looks a lot like the pattern right before the PV became a beast back in 2019. It shows how fast things can change.
Let's talk about what's nudging the PV toward one of these doors. What are the boundary conditions, the non-atmospheric factors pushing things around?
There are 3 big ones to watch. First is the snow cover extent, or SCE, especially across Eurasia. Right now, the low snow cover there is basically unprecedented.
Why does snow cover in Siberia matter for the air over, say, Chicago?
It's a classic feedback loop. Less snow means the ground absorbs more of the sun's heat. That warmth helps build up domes of high pressure over the Ural and Scandinavian mountains.
And those high-pressure domes act like battering rams against the PV.
Exactly, they push against it, forcing it to weaken and stretch. So low snow cover is a really strong signal for a weaker PV.
That's a fascinating link. What's the second factor?
Arctic sea ice. We're seeing negative anomalies, meaning less ice than normal, focused in the Barents Kara Seas, up north of Scandinavia and Russia.
And less ice means the ocean releases more heat into the atmosphere.
A ton of heat and moisture. This is considered a very robust signal for an overall weaker PV this winter. And the fact that it's happening in the Barents Kara is especially potent for creating that blocking high pressure we just talked about.
And the third factor, sea surface temperatures, SSTs.
A bit of a mixed bag here. We have La Nina conditions in the Pacific, which often favors colder weather in the northern U.S. But at the same time, the rest of the northern hemisphere oceans, especially the North Pacific and Atlantic, are still well above normal.
So what does this all mean? The atmosphere is currently reshuffling the deck of weather cards for all of us. The boundary conditions, the low snow, the low sea ice, are all screaming for a weak PV. But the short-term models are temporarily betting on a strong one.
It's a massive atmospheric power struggle. What we saw in early December was just round one. We're waiting to see if those boundary conditions are strong enough to force the atmosphere down the path of scenario 2 or 3.
That's the key takeaway. The pattern we have now in December probably will not be the pattern we have in January and February. The real fight for winter is just getting started.
Indeed. And if you're wondering where the greatest uncertainty is, it's in that critical holiday intermission period. Based on what's happening over Siberia, we should be looking for a return of a colder pattern in the eastern U.S. right around the turn of the calendar year, no matter which big scenario wins out.
But the truly provocative thought is this. The models predict the PV is strengthening, which should mean mild weather. But will it successfully protect itself? Or will that Rodney Dangerfield of disruptions, the stretched PV, make a surprise return during the holidays, giving winter weather fans an early New Year's gift?
That is the high-stakes question we're left with.
Don't forget to like and subscribe for the next episode on While We Were Distracted.